All right, let's dive in. Today we're tackling something pretty awesome, the YOLO algorithm.
YOLO.
You only look once.
Catchy, right?
It is, and it kind of gives you a hint about how powerful this thing is.
Oh, absolutely.
We're talking computers seeing the world just like we do, recognizing objects in real time.
And doing it incredibly fast, with amazing precision.
Exactly. So we've got a ton of research articles all about YOLO, ready to unpack.
Buckle up. It's going to be a wild ride through the world of computer vision.
Now, you've probably seen YOLO in action without realizing it.
Oh, for sure.
Self-driving cars,
Yeah.
facial recognition, even those filters we all use on social media.
All powered by object detection.
Right, which basically means a computer can find and pinpoint specific things within an image.
Like, imagine a packed city street, cars, people, signs, everything.
Right, so before YOLO came along, computers had this clunky two-step process to figure out what was in a scene like that.
It was slow, for sure.
Well, first, they'd try to guess where an object might be.
Kind of like a shot in the dark.
And then they try to figure out what it was.
Not very efficient.
Not at all. And definitely not very accurate.
It was like trying to find a needle in a haystack, but first you had to guess where the haystack was.
Haha, exactly. But then YOLO came along and changed the game.
Completely revolutionized things.
It looks at the entire image in one go.
All at once, just like the name says.
You only look once,
It's like reading a whole sentence in a glance.
instead of having to sound out each word.
Much faster, much smarter.
Okay, so YOLO takes this shortcut, analyzes the whole picture at once.
Right.
But how does it actually see and understand what's in the image?
It's got to be more than just a shortcut, right?
Yeah, there's going to be some serious brain power behind it.
Well, it's not magic, but it's pretty darn close. YOLO uses these things called convolutional neural networks.
CNNs.
Exactly. Think of them like layers, one on top of the other, and each layer is recognizing patterns.
Layers of pattern recognition.
Yep. And as you go deeper into the layers, they get more and more abstract.
Okay, so like the first layer might be picking up basic shapes, edges, things like that.
Right. And then the next layer combines those shapes into more complex features.
I see, and so on, until it can recognize a whole object.
Exactly. It's kind of like how our own brains work,
Yeah.
but on a much faster and more complex scale.
So it's learning, essentially.
Absolutely. It's learning to see the world just like we do.
Now we need different sized boxes to wrap different shaped presents.
Right.
YOLO needs a way to accurately wrap around the objects it detects, regardless of their size or shape, too.
Oh, that's a great point. And that's where anchor boxes come in.
Anchor boxes.
They're like predefined boxes, different shapes and sizes.
So YOLO uses these anchor boxes as templates to make its predictions.
Precisely. It's like having a whole toolkit of shapes to work with instead of trying to fit a square peg into a round hole.
That's brilliant. Makes perfect sense.
It's one of the things that makes YOLO so adaptable.
So it's not just about speed, it's about accuracy, too.
Absolutely. And YOLO have gone through several upgrades over the years.
I've heard about that.
Each version getting faster, more accurate, more efficient.
So what was some of the key improvements along the way?
Well, with YOLO 2, the introduction of anchor boxes was a major leap forward, especially for detecting objects of different sizes.
I can see why that would be important. You know, like if you're trying to identify birds in a photo.
Yeah, exactly. Some might be tiny in the distance, others much closer and filling the frame. YOLO 2 handled that variation much better.
So it got better at recognizing those size differences.
Exactly. And then with YOLO 4, there was a breakthrough in efficiency.
Efficiency, so not just speed, but how much processing power it needed.
You got it. YOLO 4 introduced a new architecture called CSPNet.
CSPNet, that sounds pretty technical.
It is, but basically it was like finding a shortcut that gave you the same accuracy with less processing power.
So it could do more with less.
Exactly. This meant you could run YOLO on less powerful devices, like your phone, or even a small drone.
Wow, so not only could it see better, but it could do it without needing a supercomputer.
Precisely. It was a huge step forward in making YOLO more accessible and versatile.
I'm curious about something, though.
What's that?
What happens if YOLO thinks it sees multiple objects in the same spot?
Ooh, that's a great question. And that's where non-maximum suppression comes in, or NMS for short.
Non-maximum suppression, that's a mouthful.
It is, but it's a brilliant idea. Think of it like a referee in a boxing match.
A referee?
Yeah, YOLO might initially predict several bounding boxes for the same object, but NMS steps in and picks the one with the highest confidence score.
So it's like saying, okay, YOLO, you've got a few guesses, but this one is the most likely.
Exactly. And then it discards the rest.
So we get one clear, accurate prediction instead of a bunch of overlapping boxes.
Precisely. It keeps things clean and organized.
That makes sense. It's like having a quality control check built right in.
Absolutely. You don't want a computer vision system that gets confused by its own predictions.
Right. So let me get this straight. YOLO sees the whole picture, uses its CNN brain and anchor boxes to identify objects, and then NMS steps in to make sure we get a clear, accurate result.
You got it. That's the beauty of YOLO. It's a whole system working together to achieve amazing things.
I'm starting to see why this algorithm is such a big deal. It's not just about speed, it's about intelligence and efficiency, too.
It's the whole package. And it's changing the way we interact with the world around us.
So we've covered how YOLO works, all the technical stuff.
The nuts and bolts.
But now let's talk about what it can actually do.
The real-world applications.
Exactly. And I think when most people hear YOLO, they picture self-driving cars.
It makes sense.
Being able to spot pedestrians, other cars, traffic signs, all in real time.
That's crucial for autonomous navigation.
It is, but self-driving cars are just the tip of the iceberg.
Absolutely. YOLO's being used in so many other amazing ways.
Like what? Give me some examples.
We'll think about those incredible wildlife documentaries.
The ones where they track individual animals?
Exactly. YOLO is making that possible, helping researchers analyze animal behavior and movement patterns.
So it's not just helping cars drive themselves. It's
Right.
giving us a deeper understanding of the natural world.
It's a powerful tool for conservation and research.
That's incredible. But I have to ask, are there any areas where YOLO, doesn't quite measure up? Does it have any weaknesses?
Well, like any technology, YOLO isn't perfect.
Okay, so what are some of its limitations?
It can struggle with really small objects, for example.
Final objects, like what?
Imagine trying to identify a swarm of bees.
Oh, yeah, that would be tough, even for a human.
Exactly. Or objects that are clustered together.
Lots of things in a small space.
Right, they can confuse even the most advanced object detection algorithms.
Makes sense. And I'm guessing lighting conditions can play a role, too.
Definitely. Changes in lighting can impact YOLO's accuracy.
So it's not foolproof.
No, but those challenges are actually what drive further research and development.
So by understanding YOLO's limitations,
We can improve it?
find new ways to overcome those obstacles.
Exactly. And speaking of new developments, there's a lot of buzz about YOLO V8.
Oh, yeah, YOLO V8. I've heard about this.
It's the latest and greatest version, still in development.
And it's supposed to be a major leap forward, right?
It is. From what we've seen so far, YOLO V8 is focusing on making the technology even more accessible.
Accessible, you mean easier to use?
Exactly. It's going to have a much more user-friendly interface, simplified workflows.
So you won't need a PhD in computer science to use it.
Exactly.
Oh, yeah.
Which means more people will be able to harness its power and create amazing new applications.
That's exciting. It sounds like YOLO V8 will be like having this powerful new tool that anyone can use.
That's the goal, democratizing access to this incredible technology.
But with all this talk about advancements and new possibilities, we can't forget about the ethical considerations.
Absolutely.
We need to be mindful of how this technology is used and make sure it benefits society as a whole.
Couldn't agree more. As YOLO gets more sophisticated and becomes more integrated into our lives, we need to have open and honest discussions about its potential impact.
So we need to make sure it's used responsibly.
Exactly. For example, facial recognition technology raises a lot of privacy concerns.
And we need to address concerns about bias in algorithms, too.
Yes, making sure they don't perpetuate existing inequalities.
It's a good reminder that even the most groundbreaking technology needs to be guided by ethical principles.
We can't just focus on what's possible. We need to think about what's responsible and just.
So we've gone from the technical details of YOLO to its real-world applications, and now to the ethical considerations.
A lot to unpack.
It is. What's been your biggest takeaway from all this?
For me, it's the realization that YOLO is more than just an algorithm. It's a tool that's already shaping our world.
And it has the potential to solve some of our biggest challenges.
Exactly. Think about medical imaging, for example.
YOLO can help doctors detect diseases earlier and more accurately.
Potentially saving countless lives. And in agriculture, it can help farmers optimize their yields, reduce their environmental impact.
It's amazing to think about the possibilities.
The possibilities are truly limitless, and that's what makes YOLO so exciting.
Yeah, it's mind-blowing when you think about it, how this technology is evolving from self-driving cars to, revolutionizing healthcare and agriculture.
It is, isn't it?
It feels like we're only just beginning to explore what YOLO can really do.
Just scratching the surface.
What I want to hear from you, what's been the most fascinating part of this deep dive for you?
What really stood out, I wonder?
Was it the way YOLO processes images in one go, like super fast, like a visual genius?
Yeah, that's pretty amazing, right?
Or maybe it's the sheer range of applications tracking wildlife, helping doctors make like life-saving diagnoses.
The potential is just incredible.
Maybe you're already thinking about how you could use YOLO in your own work or even just, in your everyday life.
I bet there are so many possibilities we haven't even thought of yet.
Whatever sparked your interest, whatever it was, hold on to that thought.
Let it be the starting point for your own exploration.
Because this whole world of computer vision, it's vast, it's constantly evolving.
There's always something new to discover.
And understanding YOLO, it's like having a key that unlocks a whole new universe of possibilities.
Who knows, maybe you'll be the one to come up with the next groundbreaking application for YOLO.
Or discover a new way to make it even more powerful, even more beneficial for humanity.
That's what I love about this field. The future is wide open.
That's it for our deep dive into the YOLO algorithm. Until next time, keep those brains buzzing.